1.3.1, the order of operations. There's an agreed upon order in which we would do mathematical operations if there's more than one in a problem. Like here's an equation, a mathematical statement indicating that a value of two mathematical expressions such as 2 times 2 and 1 times 4 are equal. An equation is written using the equal sign in this manner. 2 times 2 equals 1 times 4. It says the following equation is a good example. 6 plus 3 times 5. If we say 6 plus 3 is 9 times 5 is 45, that's the wrong answer. We're supposed to multiply 3 times 5 first to get 15 and then add 6 and get 21. So it says, if the answer is to be accurate, the operations must be done in the proper order. For simple equations, the correct order is multiplication, division, addition, and subtraction. Use a simple memory aid to remember this. MDOS. It's my dear Aunt Sally. You might have heard PEMDAS, parentheses, exponents, multiplication, division, addition, subtraction. Basically, it tells us to do the highest level of operation first, and then you go down subsequently down the line doing the simpler and simpler until we get to addition and subtraction. So in our original example here of 6 plus 3 times 5, even though it's written with the 6 first, we would multiply the 3 times the 5 first because it's multiplication, and that's a higher order of operation than addition. So it says you use a second memory aid, PEMDAS, for more complicated equations. Remember the memory aid with this phrase, please excuse my dear Aunt Sally. Take the first letter of each word. P is parentheses, E is exponents, M is multiplication, and D is division, A is addition, S is subtraction. A good example of that, a good example of that is the formula for converting Celsius into Fahrenheit. Fahrenheit equals Celsius times 1.8 plus 32. So whatever your Celsius reading is, you first multiply it times 1.8, and then you add 32, and that equals Fahrenheit. If you wanted to go the other way, if you want to find out what the Celsius value of a temperature is from Fahrenheit, you would do Fahrenheit minus 32. I'm going to have to put those into parentheses to make sure that that's done first. And then we would divide it by 1.8. And that equals Celsius. Okay, so those are formulas. And when you have an equation or a formula, you want to calculate it in the order of operations. Okay, that's what they're talking about here, the order of operations. So it says the P represents the parentheses and the E represents exponents. If an equation has an operation in parentheses, such as parenthesis 6 times 3, close parenthesis, do that operation first. Handle any exponents next. This module explains them only briefly, so do not get too worried about if they're a new concept to you. And then we would do multiplication and division next, and then we would do addition and subtraction last. It says an exponent is a superscript number next to a normal size number. For example, 6 raised to the power of 2. This means that 6 would be multiplied times itself, 6 times 6. The exponent 2 specifies that two 6's get multiplied together. If the exponent is 3, 6 to the power of 3, then 3 6's get multiplied together, 6 times 6 times 6. And you can see 36 times 6 is 216. So it very quickly increases the value of a number. Numerators and denominators. This module introduces working with fractions. Think of a fraction as another way to write a division problem. The number on top of a fraction is called the numerator. It is identical to the dividend in long division problems. The lower number called the denominator is the same as the divisor. The biggest difference between fractions and long division is that most fractions encountered on the job site result in a quotient that is less than 1. In the average long division problem, the quotient is usually greater than 1. But in the end, fractions simply represent another way to write a division problem. If I were to give you an example of that, I would say, and it goes back to basics, let's say we have a pizza pie. There we go. And if we cut this pizza into 4 equal pieces, I know that doesn't look equal, but let's just pretend that's equal. 4 equal pieces. If I take one of these pieces for myself and I'm going to eat it, I've eaten one of the 4 pieces. That's 1/4. Now let's say I'm hungry and I continue eating and I eat an additional slice of pizza. Now I have eaten 2 of the 4 pieces. Well, this 2/4 can actually be reduced to 1/2. And we want to do that. We don't want to write a fraction such as 2/4 because 2 is divisible by 2 and 4 is divisible by 2. So we want to reduce that fraction to its simplest term of 1 divided by 2. So in this example, I've eaten half of the pizza. I ate 2 of the 4 original slices of pizza. I've eaten 1/2 of the pizza. And if you look at the pizza, you can see this is indeed 1/2 of the pizza. So the numerator is the number on the top, and the denominator is the number on the bottom. Their denominator and on the top is the numerator. The way I was taught to remember that is the denominator starts with D, the denominator is down. It's on the bottom. So the denominator, D, is down. Number of courses. Masons often use the term courses when erecting block walls. This refers to the number of block rows stacked up to make a wall. A 15-course wall made from 8-inch by 8-inch by 16-inch concrete blocks is 10 feet high. So it's 8 inches times 15 divided by 120 inches, or divided by 12 inches per foot. So 8 times 15 is 120 inches, and 120 inches divided by 12 inches equals 10 feet. So a 15-course wall is 10 feet tall. Very good. 1.3.2 study problems, multiplying and dividing whole numbers. Okay, we've done some multiplication and division of whole numbers. Supervisor sends a trainee to the truck for 180 special fasteners. Fasteners come in bags of 15. How many bags will the trainee bring back? Well, let's see. Okay, so we'll get a blank page here, and we're saying that he needs 180. I'll leave it green, that's okay. Oh, let me use my right, sorry. There we go. So 180 fasteners is how many he needs. Each bag contains 15 fasteners. So how many bags would we need? If we put our division bar and we put the 15, the dividend goes into the divisor, 180. 15 goes in 18 once, so I'll draw 1, and I'll bring down my 15, and 18 minus 15 equals 3. Well, now I need to bring down the next digit. I'll bring this 0 down, and I'll ask myself, how many times does 15 go into 30? And the answer is 2. 15 times 2 is 30. So we'll write the 30 underneath and subtract, get 0 with a 0 remainder. So it'll take 12 bags of fasteners. 12 bags at 15 fasteners per bag will give us 180 fasteners. So it says if the following amounts of lumber need to be delivered to each of 2 different staging areas at 4 different job sites, how many total boards of each size are needed? Well, let's stop and think about what they just said, because they've given us a lot of information here. They said each job has 2 staging areas. There are 4 different job sites. 2 times 4 is 8. So we're going to need 8 setups. We're going to need 8 sets of these pieces of lumber in order to be able to put 1 set at each staging area. So the 65 2x4s, I'm going to go back to black here. So we have 65 2x4s for 8 staging areas. 8 times 5 is 40. I'm going to draw the 0 and carry the 4. 8 times 6 is 48, plus 4 is 52. We're going to need 520 2x4s. Okay. I'm actually going to move. Let's see, where's my cursor? There. Let me grab this and move it. There we go. Now I'll go back to my pen. The next one are 2x8s. We need 45 of them. So we need 45 2x8s, 8 staging areas. Again, we'll multiply 8 times 5 is 40. Write the 0 and carry the 4. 8 times 4 is 32, plus 4 equals 36. We need 360 2x8s. And lastly, we need 25 2x10s, 8 staging areas. 8 times 5 is 40. We'll draw the 0, carry the 4. 8 times 2 is 16, plus 4 is 20. We need 200 2x10s. There. Again, if you have any question about anything that I'm doing, ask your instructor. You can also put it in the comment section of the video, and I'll try to answer your questions. Very good. All right. One plumbing job requires 45 meters of PVC pipe, and a second job requires 30 meters. The pipe comes in 6-meter lengths only. How many sections should the plumber buy? Well, that's a good question. How much pipe will be left over, assuming that there are no errors? Okay. So, on one job, he needs 45 meters of pipe. So if we have 45 meters divided by, each piece is 6 meters long. So we'll divide 45 divided by 6. 6 goes into 45 7 times. 7 times 6 is 42. So we'll write the 42. We'll subtract 42 from 45, leaving us 3. Now, at this point, we're going to put a decimal point right there, because this is the ones column, and if we go to the right of the ones column, we're now talking about decimals. We're talking about numbers that are smaller than 1. So here, we're going to bring down an imaginary 0, bring it down and put it next to the 3, and now we'll say 6 goes into 30 5 times. 6 times 5 is 30. So write the 30, we'll subtract, and we have no remainder. So for the first job, we need 7.5 pieces of PVC pipe. You're not allowed to buy a half of a PVC pipe. So he's going to have to buy 8 pieces for the first job. And we're going to have half of that, 3 meters left. They were saying that they're measured meters, so we're going to have 3 meters left over. Now, if we go to the next job is 30 meters of pipe, we'll put our division bar, divide by 6 meters. Well, 6 times 5 equals 30. And they said if we have no mistakes, we should only need 5 lengths of pipe for this job. And we needed 8 for the other job. So we're going to need a total of 13 PVC pipes that are 6 feet long. I'm sorry, 6 meters long. 6 meters long. We're going to have 3 meters left over. We're going to have a half of a 6-meter pipe left over. There, I'm trying to write and talk at the same time. All right, very good. So when you have these word problems, you have to just try to take a look at it and think, how do we need, what are they asking me? What do I need to do mathematically? This one's going to be, I think, multiplication. It says if a crane rental company charges $800 per day, $3,400 per week, and $10,500 per month, how much would it cost to rent the crane for 3 days? Well, if we're going to rent it for 3 days and it's $800 a day, then we're going to multiply $800 times 3 days. And 3 times 0 is 0, and 3 times 0 is 0, and 3 times 8 is 24. So $2,400 for 3-day rental on the crane. And it says, how much would it cost to rent the crane for 12 days? Well, I think we'll save a little money if we rented it for 2 weeks and 2 days. Each week is 5 days long, they're saying here. So we're going to rent the crane for 2 weeks and 2 days, which would be 12 days. So 3,400 times 2 weeks. We'll do 2 times 0 is 0, 2 times 0 is 0, 2 times 4 is 8, and 2 times 3 is 6. It's $6,800 to rent the crane for 2 weeks. Then we're also going to have to rent it for an additional 2 days. So we'll do 2 times 0 is 0, 2 times 0 is 0, and 2 times 8 is 16. Sorry, my zeros look like sixes. That's my fault. So $1,600 for an additional 2 days. And we'll add these two together to find what the total is for 12 days. So 0, 0. 8 plus 6 is 14. We'll carry the 1. 6, 7, 8. So for 12 days to rent that crane would cost $8,400. It says, how much would it cost for 1 month and 11 days? So again, we're going to break it down. We're going to do 1 month. We're going to do 2 weeks. We're going to do 1 day. And that will give us the price of renting the crane for 1 month, 11 days. So the price for 1 month is $10,500. Price for 2 weeks is $3,400 times 2. 2 times 0 is 0, 2 times 0 is 0, 2 times 4 is 8, and 2 times 3 is 6. So $6,800 for 2 weeks. $6,800 for 2 weeks. And then 1 additional day is an additional $800 for that 1 day. And that's how much it would cost to rent the crane for 1 month and 11 days. Add all of these up. And 8 and 8 is 16, and 5 is 21. Carry the 2. 6 plus 2 is 8. And the 1 is all by itself. So it would cost a grand total of $18,100. I don't know what I've done here. Something popped up. There we go. I don't know if you could see that. I'll have to edit it. But $18,100 to rent the crane for 1 month, 11 days. Okay, very good. So here's our section 1 review. Given the number 92,475, which digit is in the 10,000th place value column? So let's take a look at this. 92,475. Which digit is in the 10,000th place value? Well, there's 1, tens, hundreds, thousands, and 10,000s. 9 is in the 10,000s place value. So the answer is D, 9. What is the distance around the foundation? Oh, okay, I'm not going to do that one. That's one that you should do yourself. Go in the book and try to calculate the perimeter, around that foundation in figure SR01. There it is. So they've given you all of these. See if you can calculate how far it is around that perimeter. And then the third one says, how many concrete blocks, like the one shown in figure SR02, are required to erect a 2-foot high wall for the foundation shown in figure SR01? And again, I'll let you look at that. You can try to calculate that on your own and talk with your instructor about it. See what his answer is. Okay. 2.2.0 fractions. Name fraction types and calculate with fractions. So after studying this, you should be able to define equivalent fractions and calculate their lowest common denominators. Define improper fractions and convert them into mixed numbers. Add and subtract fractions, multiply and divide fractions. There's no performance task in this section. So the lower number of a fraction is called the denominator. Denominator is the part of a fraction below the dividing line. For example, the 2 and 1/2 is the denominator. It is equivalent to the divisor in a long division problem. The numerator is the part of a fraction above the dividing line. For example, the 1 and 1/2 is the numerator. It's equivalent to the dividend in a long division problem. So it's 1 divided by 2 or 1 divided by 3, or numerator divided by the denominator. In the fraction 1/2, the 1 is the upper number or numerator and the 2 is the lower number or denominator. A fraction in which the number and the numerator and the denominator are identical are always equal to 1. So if you see a fraction that says 2/2, then that's equal to 1. 8/8, 16/16, all those are equivalent to 1. 2.1.0 Equivalent fractions and lowest common denominator. Equivalent fractions are fractions having different numerators and denominators, but still having equal values, such as the fractions 1/2 and 2/4. 2/4 can be reduced. So 1/2, 2/4, 4/8, those are equivalent. They have the same value. Figure 2 shows the individual units making up 1/2, 1/4, 1/8. They're on a ruler or on a measuring tape. So this is 1/2, this is 1/4, this is 1/8. 2.1.1 Finding equivalent fractions. To someone used to working with fractions, 1/2, 2/4, and 4/8 are obviously equivalent fractions. However, there's a mathematical way to confirm this. Determine each fraction's value by dividing the denominator by the numerator. So 2 divided by 1 equals 2, 4 divided by 2 equals 2, and 8 divided by 4 equals 2. Since the quotients match, the fractions are equivalent. To change 1/2 into 16ths, work out what number times 2 gives 16. The answer is 8. So multiply both the numerator and the denominator by 8. So 1/2 times 8/8 equals 8/16. That's an equivalent fraction to 1/2, but it's using 16 as the denominator. 2.1.2 Reducing fractions to their lowest terms. If something's measurement is 4/16, it may be easier to work with by reducing the number to its lowest term. Calling out a measurement of 4/16 on a construction job will probably cause a few puzzled looks. To find the lowest terms of 4/16, use division as follows. Determine the largest number that divides perfectly into both the numerator and the denominator. In this case, it's 4. With a little practice, this is an easy mental task. If there's no number other than 1 that divides perfectly into both numbers, the fraction is already in its lowest term. For this example, however, the largest number is 4. So 4 divided by 4 is 1, and 16 divided by 4 is 4. So 4/16 is equivalent to 1/4. 2.1.3, comparing fractions and finding the lowest common denominator. Remember, the denominator is the number on the bottom of the fraction. And to add or subtract fractions, we have to have the same denominator. So that's what they're teaching you here, how to make that denominator, how to find the lowest common denominator. So which measurement is greater, 3/4 or 5/8? Tackle this question by asking a different question. Which is longer, 3 sections of a board cut into 4 equal pieces, or 5 sections of a board cut into 8 equal pieces? So here are 2 boards that are the same length. They took the board on the bottom here and they cut it into 4 equal pieces. 3/4 is shaded in yellow. The top board they cut into 8 equal pieces and they shaded 5/8. And you can see 3/4 is larger than 5/8. So comparing fractions with different denominators is challenging. While the visual example makes it obvious that 3/4 is more than 5/8, this method is inappropriate for the job site. A mathematical approach makes the task easier. If the fractions have the same denominator, just compare the numerators. Fractions with different denominators require another method. So we're going to have to try to find the lowest common denominator. And in this case, 3/4 and 5/8, 8 would be the lowest common denominator. We can change 3/4 into 6/8. So multiply the 2 denominators together. 4 times 8 is 32. The result is 32. It's a common denominator because each denominator divides into it perfectly given a whole number result. Convert the 2 fractions so that both have the same denominator, 32. So they're going a different route than I was going. They want to multiply by 8/8. So 3 times 8 is 24, and 4 times 8 is 32. So 3/4 is equivalent to 24 32nds. 5 times 4 is 20, and 8 times 4 is 32. That gives us the same denominator, but we can see that 24 32nds is larger than 20 32nds. It says, consider the lumber example again. The fractions 3/4 and 5/8 are already in their lowest terms. Comparing the denominators shows that 8 is a multiple of 4. Calculate the equivalent fraction with a denominator of 8 or of 3/4. So 3/4 times 2/2 equals 6/8. Now we can compare 5/8 and 6/8. It's very easy to see that 6/8 is larger than 5/8. 2.1.4, study problems, finding equivalent fractions. So let's look at these problems here. Find the equivalent for the following fractions. 1/4 equals how many 16ths? Well, what do we have to multiply 4 by in order to get 16? We have to multiply 4 by 4 to get 16. So if we multiply the denominator by 4, we're going to also multiply the numerator by 4. And the equivalent fraction is 4/16. That's equivalent to 1/4. 2/16 equals how many 32nds? Well, we'd have to multiply the denominator 16 by 2 in order to get a denominator of 32. So we'll also multiply the numerator by 2, and we'll get 4/32nds, and the equal fraction to 2/16 is 4/32nds. Here 3/4 equals how many 8ths? Again, we have to multiply the denominator by 2 in order to get 8 as the denominator. So we'll multiply the numerator by 2 also. We'll get 6/8. D. 3/4 equals how many 64ths? Wow, okay. So 4 times 16 is 64. So we're going to multiply multiply the numerator, 3, by 16. And we get 48/64. 48/64. And finally, 3/16 equals how many 30 seconds? Again, we're going to multiply the denominator by 2 in order to get 32. So we'll multiply the numerator by 2, and we'll get 6 30 seconds. And now this says, without using a calculator, find the lowest term for each of the following fractions. And number 6 is 2/16. If both numbers are even, just divide by 2 and see what you come up with. So 2/16 is equivalent to 1/8. We'll divide the numerator by 2. We'll divide the denominator by 2 as well. Again, number 7, same thing, it's 2/8. We're just going to divide it by 2 2's. And 2 divided by 2 is 1, and 8 divided by 2 is 4. So the lowest term in this case is 1/4. 12 30 seconds. We have to be careful here. 12 30 seconds, if we were to divide by 2, would give us 6/16. But 6/16 can also be reduced. So we could go to 3/8. If we took 12 30 seconds and divided by 4/4, 12 divided by 4 is 3, and 32 divided by 4 is 8. So we get 3/8. 4/8. If we divide by 4/4, we'd get 1/2. 4/64. If we divide by 4, we'd get 1/16. 4 divided by 4 is 1, and 64 divided by 4 is 16. Find the lowest common denominator for the following pairs of fractions. So we want to find a denominator, the number on the bottom, that is the lowest common denominator for 6 and 4. And I would say 4 times 6 is 24. But I could say 4 times 3 is 12. And 2 times 6 is also 12. So we could have 12 as a common denominator. We could multiply 2/6 by 2/2. And we could multiply 3/4 by 3/3. And we'd end up with a denominator of 12. Here's 1/4 and 3/8. Well, 4 and 8 are 4 is a multiple of 8, so we could just double 1/4 to be 2/8 and 3/8. So 8 is the lowest common denominator for those two fractions. Number 13 is 1/8 and 1/2. And again, 2 goes into 8, so 8 will be the lowest common denominator. We'll multiply 1/2 by 4/4, and we'll get 4/8 and 1/8. So 8 is our common denominator. 1/4 and 3/16. Again, we'll multiply 1/4. We'll multiply the denominator by 4 to get 4/16 and 3/16. So B, 16, is the lowest common denominator. And lastly, I have 4 30 seconds and 5/8. 8 times 4 is 32. So we can have the common denominator of 32. You know, we could actually have a common denominator of 16, couldn't we? We have 4 30 seconds, and we could divide that by 2 and have 2/16. And here's 5/8. Well, we could multiply that times 2 and get 10/16. But you know what? Now that I see that we have 10/16 and 2/16, we could divide both sides by 2 and get 1/8 and 5/8. So I'm going to say 8 is our lowest common denominator, D. 2.2.0, improper fractions and mixed numbers. An improper fraction is one that has a numerator larger than the denominator. And a mixed number is a number made up of a whole number and a fraction. So, an improper fraction, a fraction whose numerator is larger than its denominator, for example, 8/4 and 6/3, those are improper fractions. An improper fraction has a larger numerator than its denominator. The fractions 43/6, 19/16, and 55/8 are all improper fractions. Converting an improper fraction into a mixed number makes calculations easier. Let's see what a mixed number is. A mixed number is a combination of a whole number with a fraction or decimal. Examples of mixed numbers are 3 and 7/16, 5.75, and 1 and 1/4. Those are mixed numbers. A mixed number consists of a whole number combined with a fraction. The mixed numbers 7 and 1/6, 1 and 3/16, and 6 and 7/8 are equivalent to the improper fractions 43/6, 19/16, and 55/8. Some improper fractions convert up to a whole number without a fraction. For example, the improper fraction 42/6 converts to the number 7. Remember, fractions are just another way of writing a division problem. To convert an improper fraction to a mixed number, perform the division. Then we'll see what our remainder is. The following steps to demonstrate converting an improper fraction, 67/32, to a mixed number. First, divide the numerator by the denominator. The denominator must be able to be divided into the numerator at least once, or the fraction is not an improper fraction. Set up the problem on a paper if necessary. So let's go half screen, and here we go. Okay. So we're going to do 67/32. So that's what we're going to do. We're going to write down what they have over here. We're going to divide 67. Oops, what happened? 67. We're going to draw our division bar and put 32 out here as the dividend. So 32 times 2 is 64. So I'll put a 2 above the division bar, and I'll write my 64 underneath the 67, and then we'll subtract 64 from 67, and we'll get 3. So 3 will be our remainder. It's 2 with a remainder of 3. And what we'll do is put that 3 over our 30-seconds. So it's 2 and 3/32. That's our mixed number. 2 and 3/32. Let's see what they did. They did the division the way we did, and they came up with 3 as their remainder. The quotient of the problem is the whole number part of the mixed number. Any remainder becomes the fractional part's numerator. Retain the original denominator, so 2 and 3/32. Very good. 2.2.1, study problems. Changing improper fractions to mixed numbers. Change these improper fractions to mixed numbers. So we have 35/8. So first we're going to write the 35, the numerator, 35/8. Put our division bar, and we're going to divide it by 8. And 8 times 4 equals 32. We'll do our subtraction. 5 minus 2 is 3. That's a remainder, 3. So we're going to end up with 4 3/8. Remember, we're going to put the original denominator underneath. The remainder is our numerator, 4 3/8. 97/16. Write the 97 and draw our division bar. 16ths. There. Let me think here for a second. 32, 64, 80, 96. I believe it'll go in 6 times. 6 times 6 is 36. 3. 6 times 1 is 6 plus 3 is 9. So 16 will go into 97 6 times. It equals 96. We do our subtraction. We end up with a remainder of 1. So it ends up to be 6 1/16. That's our answer. 6 1/16. 13/4. Write our numerator. Draw our division bar. Put the denominator as the dividend. 4 times 3 equals 12. So 4 will go into 13, 3 times is 12. We do our subtraction, 3 minus 2 equals 1. So remainder 1. So we have 3 1/4. We'll put our original denominator underneath the remainder, 3 1/4. 14/5. So we'll write the numerator as the divisor. Write the denominator as the dividend. So 14/5. 5 times 2 is 10. Do our subtraction. We have a remainder 4. So our answer will be 2 4/5. With the original denominator underneath the numerator, the remainder. And last but not least, we'll do 48/16. So here's 48. Draw our division bar. And we'll divide that by 16. And here, times 3. 6 times 3 is 18. 3 times 1 is 3. Plus 1 is 4. There's no remainder. Our answer is the whole number 3. That's our answer to that one. Okay.